We're now ready to dive into our data analysis power hour. There's an outline of the lecture over here. So our two main topics are going to be how to represent data and summarizing data. And as we talk about how to represent data, we'll get a better sense of what data is in the first place. So you can see that under how to represent data, there are three main ways to represent data: a list of numbers, a frequency distribution, or a bar graph, which is also known as a histogram. Okay, so list of numbers. That's essentially the definition of what data is, lists of numbers. And they're usually taken from surveys or measurements. So if you go to page 286 on your book, you'll see a story that talks about a survey giving you a raw list of numbers. Go to page 286. A survey was taken to find the number of children in each of 25 families. A list of the values collected in the survey follows. In your book, you see 25 numbers that are not in any particular order. The first number in this list is 1. So what does that mean again? It means that the first family surveyed had 1 child. The next family surveyed had 2 children, etc. These numbers are not very useful to us when they're all scrambled up in random order. They're going to be easier to organize and work with when we put them in order. So the ordered list is the conceptual basis for all other representations of data. And what I've done on your handout here is I've taken the 25 numbers in that list and just ordered them from smallest to largest, and I counted them with repetitions, which is extremely important. The list of numbers 0, 1, 2, 3, 4, and 5 is much different from the list 0, 0, 0, 1, 1, 1, 1, 1, etc. The repetitions matter quite a lot. Okay, so that is obviously the first way to represent data. You can just write out a long list of numbers in order. Not only is that boring, but it's also very awkward and tedious, because as we know, data lists can get to be very long. We don't want to carry around lists of hundreds or thousands of numbers with us. We need to be able to abbreviate or summarize them. So let's do that with our first tool, the frequency distribution. A frequency distribution is a summary of a long list of numbers that shows all the different values in the list, calling them x, and the frequency, or the number of times that each number is repeated, which is usually called f of x. So this table here represents the same data up here. X, all the different numbers in the list are 0, 1, 2, 3, 4, and 5. F of x, frequency, means how many times they're repeated. How many zeros are in the list? 3 of them. That's why there's a 3 here. How many 1s are on the list? 5 of them. Right? There are 5 1s. There are 7 2s. So I need you to be extremely clear that these numbers over here are not necessarily, they do not represent numbers that are in this list. Sure, there's a 3 here and there are 3s here, but that's a coincidence. Because you'll notice there's a 7 here and there's a 6 here, but there are no 6s or 7s actually in the list. This again means that there are 7 2s. There are 6 3s. Notice that if you add up all the frequencies, they add up to 25, which is the size of the list. That value is usually called n for number. Now, underneath that table in your book, you're going to see another version of the table, but instead of the 3, the 5, and the 7, you see percents, 12%, 20%, 28%. Where did those come from? Well, basically, we're just turning these whole numbers into fractions, decimals, or percent. So let me copy and paste this part of the table down here. Now, we decided that there are 25 numbers in the list altogether. So wouldn't that mean that the zeros constitute 3/25ths of that list? 3/25ths? And that's why we write 3/25ths here. What percentage of the number, or what fraction of the values are 1s? 5/25ths. So each of these frequencies can just be turned into a numerator over 25. When we add them all together, we get a total of 25 out of 25, which is 1. And when we do that, We can call these relative frequencies, or we can call them probabilities. That's what the capital P stands for. Or proportion, if you like. So whether we call these numbers 3, 5, and 7, or 3/25, 5/25, and 7/25, actually doesn't matter. It's still the same distribution. We can turn each one of these fractions into a decimal. If you add up all these decimals, then their total probability is 1. You can turn each of those decimals into a percent, which is what you see in your book. If you add all those percents together, you get 100%. So a frequency distribution or a probability distribution should always add up to 1. All of these are equivalent. Now it's very important, again, to be able to do these things backwards. So in this example, we took a list of whole numbers and we turned them into fractions, decimals, or percents. But what if I had given you a fraction, decimal, or percent first and then asked you to turn them back into whole numbers? Well, that's kind of harder, but also kind of easier, because there are actually many, many ways you could do it. For example, if I had doubled all these numbers, if I had turned this 3 into a 6 and I turned this 5 into a 10, and if each one of these numbers got doubled, so that now the frequencies all add up to 50, you know what? It's still the same distribution, because 6 out of 50 reduces to 3 out of 25. The same. Okay? So we don't have to be super careful about exactly what whole numbers we are choosing. We could say the first case or the second case. They both work. But we need something that's proportional to these values. So in this example, this is a new list of numbers, 5, 10, 15, 20, and 25. Each one of them has a certain probability. How could you turn those probabilities or those percents into whole numbers? Again, the answer is there's a multitude of ways we could answer it. So let's just pick the easiest one. And that would just be to turn each one of these percents into its own whole number. There, that would be one example. That would really represent the same distribution. And those numbers might be easier to work with when you're calculating averages or whatnot. The bar graph. So we can turn a frequency distribution very easily into a bar graph. If you turn to page 290 of your book, you'll see an example of that. And I have copied that example here. Okay, so let's see how this is related to this table. We're using the percents. So for example, you see that the zeros make up 12% of the list. And when we look at our bar graph, number of children, 0, relative frequency or percentage, 12%. So each one of these percentages is just going to get turned into the height of a rectangle. Number of children, 1, should be 20%. 20%. 2 children, 28%, etc., etc., etc. They all add up to 100%, which basically means that the area under this curve is 1. Okay, so when we do that, we get a nice visual. It's always nice to have a visual to look at. This visual has a shape to it, and it's really going to be very helpful in a lot of the problems that we do later on. List of numbers, frequency distribution, bar graph. They're all the same thing. Again, in this bar graph, notice the number of children, 0, 1, 2, 3, 4, or 5, was written in ascending order from small to large, from left to right. That's going to be really important. The frequencies or the repetitions are vertical. To answer questions about a frequency distribution or graph, we almost always need to mentally convert it to an ordered list. In other words, this always comes back to doing the easy things backwards. On this page, we started with an ordered list of numbers. It was pretty easy to turn that into a table. It was pretty easy to turn that table into a graph. But now what if we give you a table or graph? Can you turn it back into a list of numbers? Well, you'd better be able to, because you really have to answer questions. For example, here's a new frequency distribution. you need to be able to look at this table and understand what it would look like if you wrote it out as a long list of numbers, like this one. You must be able to do that to answer these questions. Number one, what's the largest number in this list? Now, a lot of students who are new to this would say 20. They look at all these numbers and all they're seeing is numbers. They see, the biggest number here is 20, so I guess the largest number in the list must be 20. I hope you can recognize that is wrong. Because remember, there are no 20s in the list. There are 29s, but there aren't any 20s. What are the actual different numbers in this list? They are 3, 8, 9, 12, and 15. What's the largest one? 15. Now, what's the most common number in this list? Well, there are 4 3s, there are 10 8s, there are 29s. That one must be the most common because 20 is the highest frequency, and therefore the 9 is the most common number in the list. What's the fifth number in the list? Very easy to get fooled here. A lot of students would say 1, 2, 3, 4, 5, 15. Nope, it's not that obvious. So let's see, what do these numbers mean again? There are some 3s. How many 3s are there? There are 4 of them. Okay, let's put them, you don't have to put them on paper, but you should at least put them in your mind. And then what happens next in the list? There are some 8s. How many 8s are there? A whole bunch of them. Okay, so I'm going to ask you again, what's the fifth number in the list? It is 1, 2, 3, 4. It's this 8 right here. How many numbers are in this list altogether? And I don't want you to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because that is wrong. Remember, to calculate the total number of values in the list, we have to add all the frequencies. So if you add all these numbers together, all the frequencies, you'll find that there are 50 numbers in the list. So if you're a little rusty on that, I would probably recommend that you go back and replay it again, because this skill is just so important. You're going to have to be able to do this at the snap of a finger on this test. All right, let's try turning a graph into a list of numbers so we can understand questions like this. So on this graph, in order to not make it too easy, I just labeled these numbers with variables A, B, C, and D. And the first question is, what is the smallest number in this data set? So I want you to remember that the actual numbers in the list are being represented on this horizontal axis. A, B, C, and D are the actual numbers in the list, and they're ordered from left to right. Therefore, the smallest one is A because it's the farthest to the left. Just like this picture, 0, 1, 2, 3, 4, 5. The 0 is the farthest on the left. It's the smallest one. Okay, what's the least common number in this data set? Well, remember that commonness or frequency is graphed vertically. So a number that is the least common would be the shortest vertically, and that would be C. There aren't very many C's stacked up on top of each other here. Okay, now these next two questions should be easier for you. What's the largest number in this list? I hope you said D because it's farthest to the right. And what's the most common number in this data set? I hope you said B because it's the tallest. So again, if you feel a little rusty about that, honestly, I recommend you go back and watch it again. Really think about this, because these skills are really what it's all about for a lot of problems on the data analysis. And again, since we have a picture here, I want to demonstrate something cool with a visual. Remember that with a distribution, you can shorten it, or you can make the frequencies grow or shrink, just as long as they all grow or shrink together. As long as they're all proportional to one another, it's still really considered the same data set. So if, for whatever reason, if you took all these frequencies and doubled them, that would still really represent the same distribution. Okay, so let's pick it up in the next video clip when we talk about summarizing data.